kind of bummed. I have to record during 4th or 6th. So anyways, so yesterday we got as far down, and I think I'm going to put this on because then you can see this better. Sorry, it takes me a minute to get it loaded. Excuse me, everybody. There we go. Now this should come on, and then it doesn't support it. So I got to make sure I get it. Just a minute. I know I'm recording, but I'm going to get it fixed here. So right now, let me get this going here. It should work. Okay, now it works. Okay, great. So this is how far we got on the last video, trying to go through here. And AJ, you're always welcome to ask questions, but we got as far as here. But we're now going to go into row 3. And we had a periodic table. We had a periodic table. And I think we got here, we used this one. Okay. So what we were doing was we were working on always writing out the last sublevel. And so on the first row, we write 1s2 if you're past helium, and your lithium or beryllium, you're going to say 1s2 and then 2s1 or 2s2. But if you're past beryllium, you're always going to say 1s2, 2s2, and then whatever's in the 2p, and you literally count the boxes to get over. So if it's nitrogen, you say 2p3. You only say 2p3. You don't have to say each one of these. You're going to focus in on the last one. Now, if you are in row 3, you're going to continue, but you're going to write out this 1s2, 2s2, and then you write out 2p6. So I'm underlining the full sublevels, and you're going to write out the full sublevels. You're going to write out the full sublevels every time you go through a configuration. Even when you're down here, you're going to say 1s2, 2s2, 2p6, and then we're going to say the next sublevel, then the next sublevel, then the next sublevel. You're going to continue to write the same thing down, and it's going to be this address, this location of all the electrons. Okay. Now, for some of you guys, I did not mention, this is because the period 2 group got to see this, but these are called transition metals, this section here. And then this section of S and P's are called their representative elements. We're going to actually go into these names more for the next unit, but I wanted to mention what these are called. And then down here, they're called the inner transition metals. And yesterday, I tried to show how this chart gets split up, and you put the F's inside between 6S and 5D. And you actually put 4F in between, because 4F is jumping 2 levels and the D's jump 1 level. And I'm going to show you about the D's here in a minute. Okay. So when we do row 3, when we're talking about, I'm looking for the periodic table. Here we go. We're looking at row 3. Okay. And we have sodium and magnesium. They're in the S block. And then we have aluminum to argon. They're in the P block. They're in the 3P block. And you literally just count boxes. So aluminum would be 3P1. Phosphorus would be 3P3. Chlorine would be 3P5. And argon would be 3P6, because you literally count the boxes across. Okay. So when we write this out, we're going to continue writing out. And for number 11, that's sodium. We could do number 12, that's magnesium. We could do number, let's just jump over, and we could do aluminum, but then we could do phosphorus, and let's do 15 for phosphorus, and then we could do argon, and that's 18 for argon. Okay, now these are, remember, this is your atomic number. It's also the number of electrons. So when you write this out, we're going to write 1s2, 2s2, 2p6, just like we did neon. And then we're going to write the location of the 11th electron. and that is in this box here where sodium's at, and it's in the third level. It's in the S block, and it's the first electron. So we're literally going to write 3s1, and that's the ending for neon, okay? And then we do magnesium, but magnesium is the second box, So we're going to say 3s2 for magnesium, and we're going to do the exact same thing, 1s2, 2s2, 2p6, 3s2, and that is the full ending of magnesium. See, this is the first level, this is the second level, and this is the third level, okay? And usually in past classes, especially, you know, some of you guys have taken physical science, you might have 2 dots in the first ring and 8 dots in the second ring, and then you'd have 2 dots in the third ring, but we're not really on rings. They're really in these spherical orbitals like bedrooms, and there's 2 in the 1s, and then there's 2 in the 2s, and then there's 3 orbitals in the 2p6, and they're each in a little bedroom, and they're all little places for the electrons to be at, and that's in level 1 and level 2, and then you have an outer 3s on the outside of a spherical with 2 electrons in there. So it's a little bit more than the rings, but the rings are very simple. They're okay to think of it that way, but we're actually more specific about being S's and P's, and then S's here. Now, when we go into aluminum, you're actually going to write all this out because now this is a full sublevel. So again, you're going to do 1s2, 2s2, 2p6, 3s2, because all of those are filled. And then you're going to come over here and do aluminum and put 3p1. If you moved on to silicon, it'd be 3p2. For phosphorus, it'd be 3p3, and you're basically following the pattern of each one, but you're going from 2, 3, 4, 5, 6, 7. So you put a 1 here for all of these. Here you do a 4p2 and so forth going down the columns. So anyways, I'm jumping ahead a little bit, but let's go ahead and write aluminum. It's going to be 1s2, and you're going to use your chart here. 1s2, sorry, I'm trying to do 2 things here. You're going to say 1s2, then you're going to say 2s2, and then you're going to say 2p6, and then you're going to say 3s2, and then you're going to say 3p1. Okay? And you're going to write that out. And the same for phosphorus. Everything's the same. 1s2, 2s2, 2p6, 3s2, and then you're going to go to phosphorus, but you're going to count 3p1, 2, 3, so it's 3p3. Okay? And then for argon, we're going to go all the way over. We can fill in sulfur, 3p4. That's how sulfur would end. For chlorine to be 3p5, and then argon would be 3p6. And that's going to be a full sublevel that we're going to write when we do anybody in row 4. And then we're going to write 4p6 for anybody in row 5, and so forth. So we keep going. We're going to say 1s2, 2s2, 2p6, 3s2, and then 3p6. Okay? Now, let's take a minute before we go into row 4. I want to kind of explain some other things that I kind of jumped ahead in the other videos that I've taught, but we want to look at the outermost electrons, and those outermost electrons are going to be called valence electrons, okay? So we're going to be now looking at not only the configuration, but we're also going to write out the valence electrons and focus on the valence electrons because we want to talk about the bonding that we're going to do in the next unit. So we're going to focus on valence electrons. These are the outermost levels electrons, and they have to usually be outermost levels S and P electrons. You're only going to be S and Ps. Eventually, when we get down to the Ds, we're not going to use those as bonding electrons, not directly. We're going to use these S's and these P's, and if you notice, 2 S's and 6 P's they add up to 8 electrons, 8 electrons. So we have our S and P electrons are going to end up going together to form the valence electrons, the valence number electrons. We're going to call them Lewis dots around the symbol. And I'll explain that. I'll explain that a little bit more here in our video. Okay. So what's going on is the outermost electrons are called valence electrons. We're going to draw anywhere from 1 through 8 dots around the element symbol. Okay. And there's actually a visual place in the textbook. I'm going to open to that here in a second to show you. But when you look at these arrangements, we're going to focus on the outermost electrons. And obviously, hydrogen, helium, that's its outermost already. So hydrogen would be 1 dot because it's an S1. And helium with its S2 would be 2 dots. And you can put them on the same side, or you can make helium with a dot on either side. Okay. Now, usually you're going to have all 8 to be a full level, but helium is full. It is a full level element because it's a full level. So it's very stable. These are very stable. The helium is very, 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 very stable. Okay. So let me put a little line here because it's kind of cluttering up the other part here. Okay. So you're going to focus on valence electrons. It's the outermost electrons. Okay. When we go into lithium, we're not going to look at the 1s2. We're going to focus on this part. What is the S's and the P's added together? Okay. So when we have 1s, we're going to have 1 dot. When we have 2 s's, you're going to have 2 dots. When you have s's and p's, you're going to add them together to get 3 dots. And then 4 and 5 and 6 and 7 and 8, all the way out to argon, you're going to have 8 dots. So that's going to be having 1 dot for lithium. It's going to be 2 dots for beryllium, like this. We're going to have 3 dots because we're not worrying about the 1s2. We're worrying about the highest level, the outermost level, S and P electrons. And here you have to add it. So it's going to be 2 plus 1 equals 3. So it's going to be boron with 3 dots. And usually we put them separate, but you could make them like this with 2 dots and 1. You just can't have any more than 2 dots on any given side, like the element symbol's a box. Okay. And then we're going to have carbon. Carbon's going to have 4 electrons. And so you're going to put carbon on each side. Last year, I bet you your bio teachers were talking about this and how carbon makes 4 bonds, because carbon was your main element that you guys covered last fall in bio. And then when you do nitrogen, it's going to have 5. So you're going to have nitrogen with 5 dots. And then with oxygen, you're going to have 6. And it's going to have 6 dots. You can do them all together in pairs. You can also do it like this with 1 here and 1 here. Kind of gives evidence for why water has 2 H's. Anyways, we'll go over that bonding type with Lewis dots later on in the year. Also, when you do fluorine, it has 2 and 5, and that makes 7. So you do 2, 2, 2, 2, and 1. And then neon has all 8. So neon is going to be all filled up. All these are going to be filled up. So it's very, very stable. We're going to call this a noble gas. A noble gas is what it's called. Sometimes it's called an inert gas. Okay, and it doesn't react with anything because it's got the full level. See, having 8 is called the octet rule. We want to be stable, and it's going to be called the octet rule. Octet meaning for 8. So this means that having 8 electrons is really, 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 really stable. So having 8 outer electrons, stable with 8 outer electrons, and this makes the element not want to bond with anything. When we get to bonding, we'll go into more with this rule and apply it more. Okay. Now, is there a question, Abigail? I don't know if that.
Yeah, that was me. I was wondering if all of the noble gases had 8 electrons, and if that's why they don't bond like you mentioned yesterday.
Exactly, totally. And so in the textbook, in chapter 6, which this little section of what we're covering is actually reviewed in chapter 6. Sorry, I'm trying to get it to the book here. Okay. But if you look at this visual, do you see this visual here? It has everybody in column 1, like hydrogen, lithium, it has 1 dot. And so these guys all behave the same way with 1 dot. And then the next column, they have 2 dots. Okay.
That
and
makes a lot of sense.
It does. It does. And so this part of chapter 6 really should be in 5. The author separates it. I don't even know why they do that, but they do. Okay. And they talk about the S block, P block, D block, F block, you know, and so forth. So this part of chapter 6 is really helpful. And then we have the 13 group. You literally take away 10 from it and you get 3, and you have 3 dots, because what you're taking away is the 10 Ds section here. Okay. So the actual group number represents, if you take away the 13 to 18 and take away 10, you'll get 3 dots for this family, 4 dots for this family, 5 dots for this family, 6 for the oxygen and its family, and 7 for the fluorines family. They're called the halogens. And then this is all the noble gases that don't react, which is what you're asking about, AJ, that this family here, everybody here is 8 and they don't react. Okay. So when we get into the next unit, we're going to talk about how these 2 react pretty well. And then these 2 react with each other. They react with each other to make ionic bonds. And we're going to talk more about that later, like probably January. Okay. And so this is on page 183. Sorry, I'm trying to get to the page number 183. And it's very helpful. Goes over the valence stuff. It goes over really organizing electron configuration based on the location on the table. And I have no idea why they don't teach it that way in chapter 5, but they don't. I don't know why, but I do. I teach it all together. Okay. Did that help a little bit? I hope so.
Yeah, it did.
Great. Okay. So there's one more thing I want to also show you some, and I know I've got maybe 5 minutes. So we know we don't. We have another 15 or so, I think. Yeah, we still have 15 more minutes. Okay. So the thing is I've got all this stuff and it writes out forever, right? But this is called the long form. And in your homework packet, you're supposed to write out the long form. And here, when you do this in your homework packet, okay, this is page 1. I'm hoping you're able to answer a lot of the questions, but when you do page 2, I'd like you to write it all the way out, and I'm going to explain how the D's get involved, okay? Now, this is called the long form, but now I'm going to show you a shortcut way to doing it, and it's okay to do the shortcut, except for on that homework page number 2, because I want you to do the whole thing. Is that when we're doing the next level, or when we go past from the 2nd to the 3rd, we can focus in on the outermost level like this. The outermost level is all about the bonding, the valence electrons, right? So this inner level is important, but we can actually make it a shorter way. So let me show you how we can do argon a little shorter. We could do phosphorus a little shorter by making all of this section represented by the previous noble gas and call it neon in brackets, and then just writing 3s2, 3p6. And see, what's really most important is these outermost electrons. The inner levels are important, but it's the outermost that dictate how the chemical, the element's going to react. Okay, so when you get to the end of a row, you can substitute all of the inner rows for the previous noble gas. And that would be using, okay, in the periodic table, if you have somebody in row 3, you could write neon and write 3s2 for magnesium. Or if you had like phosphorus, you could write neon and write 3s2, 3p3, because the inner part is important, but it's really these 5 last electrons is what dictate how phosphorus is going to bond. Okay. So now when we go on to row 4, like potassium and calcium is really in the 4s section, but we can just say argon and 4s1 for potassium, or argon and 4s2 for calcium, because it's really these last two electrons that dictate how calcium and potassium are going to react. Okay. Now the inner three levels are important. We can write them all out, and that's what you're doing. That's what you're doing on this homework. You're going all the way from the beginning every single time. Okay. But what we're going to be doing is showing you a shortcut here in row 4 or 4. So we're going to do, let's do potassium and calcium. And then we're going to jump over and do a couple D's, like, let's do manganese, which is number 25. We could do zinc, which is 30. And then we could do arsenic 33. And then we could end with krypton 36. Okay. Now, what we're doing here is we have potassium, calcium, manganese, zinc, and then it's arsenic, and then it's krypton. Okay. Now, potassium, because you're going to be in the fourth level, and I just moved. Okay, we're in the fourth level now. Okay, we're in the fourth level. We're going to write 4s1 for potassium, but since it's right after a noble gas, we can do all of the first levels and represent it by argon. We can write argon down and then write 4s1. We could do the same for calcium, argon, and write 4s2. Okay, and we're going to fill this in, 4s1, 4s2. And now, after that, but the really funky thing is that the D's are technically the third row, technically in name only, but they really are filled up. They're really filled up. They're really filled up by, having 3D1, and that's scandium, and 3D2 is titanium, and 3D3 is vanadium, and 3D4, I believe, is chromium, and then 3D5 is manganese. Okay. And so you literally are counting the boxes, but these guys in the middle, scandium is 3D1, 3D2, 3D3, 3D4, 3D5. And if you go down below, the Y element is 41, zirconium is 42. You literally can fill these in going down, 44, and then TC is 45. And literally, this is the last type electron sublevel. You can go to any one of them and try to count the boxes over. And time-wise, I'm going to try to help, with whatever I can. We might even have to get our own paper, because I haven't even gone over orbital diagrams yet. So I'm going to try to do that here shortly too, because I want to help you with the orbital diagrams before the end of this period here. So, okay, we go to manganese. You see how we do argon, because it's the first four levels, 4s2, and now we're doing 3D, 3D5, and we count the boxes over to 3D5. When we go over to zinc, we're literally going to count over on your table 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember how there's 5 orbitals for D's, but you double it to get 10 electrons for the actual electrons here. So we're going to write 4s2 3D, but it's going to be 3D10. Argon 4s2 3D10. And then arsenic, because now we're past it, we're going to put 3D6, 3D7, 3D8, 3D9 for copper, and then 3D10 for zinc. Okay, now that it's a full level, we're going to use this as a full level, sub-level. This is a full sub-level, and then we're going to count over to get the arsenic, which is the third box over, 4P1, 4P2, 4P3, okay, and it's going to be 4P3 here, 4P4, 4P5, and 4P6, okay? And you're going to write 4P3 for arsenic. So you're going to write argon, 4s2, 3d10, 4P3, and then krypton's going to be argon, 4s2, 3d10, 4p6. Okay. Now, what's going on with the Lewis dots is that you don't include D's or F's in the Lewis dots. Valence electrons are only going to be S and P's. So when you're a 4s1, potassium is just 1 dot. When you're calcium, you're just 2 dots. But when you get over to manganese and zinc, you don't count these 3 D's. So it's still just 2 dots. Everybody in the D block are going to always be 2 dots. Okay, zinc's going to be 2 dots. And then when you get to arsenic, you're going to ignore the D's and add the 2 and the 3 to make 5. So there's going to be 5 dots around arsenic, just like nitrogen. There's going to be 8 dots for chromium, just like neon. Okay. Hopefully that works for that. And you're going to fill these in. I don't know how much I really wanted you to do Lewis dots on the homework. I don't think I did enough, but honestly though, I know I have orbital diagrams, and I filled in, there's one paper here. You know, honestly, I don't know how much of the Lewis dots I even had you do. So I'm teaching you about Lewis dots, but we're going to be focusing more. I think we're going to focus more on those when we get to the next chapter, just because I didn't put a whole lot of them on the homework. Okay. But let me show you some orbital diagrams. And I do have a third video that's actually going to be better, since I only have a few more minutes left. But I want you to watch that third video. I know AJ's on the call class right now, but I'd like you to watch that video. And I have a paper that goes over the rules, and I want to try to show you the rules real quickly. Okay, now what we're doing is, when you do the configuration and you write out like 1s2, 2s2, 2p6, or 3s1, for instance, like this would be like sodium. And what you're doing is you're going to show arrows to represent the electrons. And remember that S's have 1 orbital. S's have 1 orbital. P's have 3 orbitals, and D's have 5. Okay. And again, this is like a short version of it. If you guys watch the orbital diagram video, I would watch that, because I go over it much slower. I do go over all the rules, and this is in more detail, mostly for an honors version, but it's definitely going over the rules. And we're talking about the lowest energy is 1s2, then 2s2, then 2p6, then 3s2, then 3p, and so forth. The 3 Ds are after the 4 S's, and this goes from low energy here all the way up to 4D, and that's high energy here. And that's the off-ball principle. So we're going to fill in 1 arrow representing 1 electron going up, and then you're going to have 1 electron going down, because in the orbitals, in the little bedrooms of their world, the electrons are both negative, and it's really hard for them to survive in the orbital together. So what happens is one spins one way and the other spins the other way, literally in the world of their orbital. And one spinning up goes up, and it's one clockwise, and the other one spinning counterclockwise going down. So in the 1s, you're going to go up and down, and 2s, you're going to go up and down. And when you do 2p's, you're going to do the first one going up, the next one going up, and the next one going up, because they want to be in separate orbitals. They want to be in separate orbitals before they have to pair up. So the first 3, this is P1, this is P2, this is P3 going up, and then you're going to go down for P4, you're going to go down for P5, and you're going to go down for P6. And that's literally how it's supposed to fill up, because they don't have to be together unless they want to be. And then we're doing 3s1. You're just going to stop here and go up. Okay. Let's say we have another element over here in the D's, like the chromium. We could do chromium. And chromium is 1s2, then 2s2, then the 2p6. And you're doing all of these 2p6, 3s2, 3p6, 4s2. So let's write that out. 3s2, 3p6, 4s2. And then you're counting over, and the chromium is right here on 3d4. So you're counting 1, 2, 3, 4, and you're going to count over to the fourth one like this, and you're going to do 3D4. So you are just going to do the low energy up, down, going up, down, going up and down, then 3D6 up, down, down. And then you're doing 4S2 going up and down. And then when you do the 3D4, they don't like to be together unless if they don't have to be. That's the Huns rule. You can stop this video and write these down at some point, okay? But you're going to basically go up for D1, go up for D2, go up for D3, go up for D4, and that's all you do. If you had D5, you go up here. That would be manganese. And then you'd start going down D6, D7, D8, D9, D10. It's just really helpful to do that, okay? And I'm hoping this is a short version of the notes, but let me show you one more thing that I have listed in Schoology. It's very helpful in this area. So I'm going to jump, jump over to this in the folder before the bell rings for the end of the class, because I want AJ, she's in the class right now, to see this. And I have in the folder, and AJ, let me know, can you see this okay when I'm flipping to here?
Yes, I can.
Okay, good. Okay, so in the learning folder, this is very helpful and very helpful. So if you go down here, we've got further down, I'm actually doing a lot of the Wednesday electron configuration. I'm making a newer version of it. And then down here, it has the Thursday video, and you definitely want to watch this because I teach orbital diagrams a little slower in this video. And then down here, I have this whole file of a teacher, and he made all of these slides, and he literally talks about it step by step, how to do the configurations in slow discussion. He talks about each step and whatnot, and you can read it and follow it if I'm going too fast for you. But he talks about every single orbital starting at 1s, 2s, 2p, 3s, from order from low to high, and all 7 levels. And then he shows it in the boxes, like my box diagram that I have here. He explains it in more detail and so forth, kind of shows you all the little sections. And then he has it literally going hydrogen, helium, all the way through, showing you how you fill the arrows up. And that's where it's very visual. He's talking about it a little slower. He's not really orally talking about it, but he has this set of slides. So if you go all the way down to say, and I'm flipping through it really quick because of time, but here's like iron, for instance. Iron is a little bit further than manganese, and it's 6 boxes over. So you go up and down, all the way until you get to the last section. And since there's 6 boxes, 1, 2, 3, 4, 5, 6, then we have 3D6. We go up for D1, D2, D3, D4, D5, and then the 6th one goes down, and that's 3D6. And then we go on to cobalt, and you have one more arrow, and it's 3D7 going down. And then we have nickel, and it goes, or arrows going up, and then down for D8. And then we have copper going up, down, then just the up for D9. And then we have this for D10 going up, down, all the way through. Everybody's paired up. And then when you go to the next guy, gallium, you're going to now be the 4P, and it kind of goes through each section, how to write out the configuration, how to draw out the arrows. I just think it's really helpful. And then I think his last slide goes all the way down to rubidium. Okay, but he tries to explain everything, tries to help you with the shortcut and so forth. So I think it's a very, very helpful. He even goes over the Fs and how you can do the Fs, and visually I show, and I know the bell's ringing. I know you probably have to go, AJ, but if you watch the videos, especially on the way I use, and I go over this other site called the ptable.com. Let me show you this real quick. If you can stay a minute here, AJ. Is this site here is really helpful. And if you go to the electron section, or I'm clicking on it, Okay, you can literally see what all the different elements, like if you go down here to cadmium, it shows you the actual configuration over here. And then it shows the arrow part here. And then it even shows how the F's play a role. So I'm going to press the Y button. This is the biggest thing, what I wanted to show, is it then shows how the F's, the 4 F's, which I didn't even get through on my paper chart. But if you did the F's, you would do it after cesium being 6s1 and 6s2. And then you'd write 4f1 through 4f14 here. And then this would be 5Ds, and that would be 6Ps. So very rarely would I ask a regular kid to do a 6th level element, but for the honors kid, they are going to go all the way over to lead or polonium and whatnot. So I just wanted to show you this version. We can unmake it wide and put the F's on the bottom again like this. So it's a very good visual to help you understand where the F's play a role in level 6 and level 7. Okay. So I think I need to end here. Again, I'm going to keep the Wednesday orbital diagram video, even the second. I'm just going to try to keep all the videos possible for kids to watch, but you definitely want to watch the Wednesday orbital diagram video just to give you a slower version of how to do orbital diagrams. Okay. So is there any more questions, AJ? I'm going to go ahead right now quickly to unrecord real quick here. So let me stop recording here.